All right, so in this video we're going to talk about tangents and circumscribed angles. Okay. Well, first I want to take this circle here, and then somehow get a picture similar to this. But we're going to talk about some of the things involved in this picture. Okay. First thing. If there's a point out here, any point, let's call it A, and then we draw a line from A to that circle, and it's tangent right there. Well, that means that it is perpendicular to that radius. We'll call this point B. And then, if we draw this same line down here, we'll call this point D. This is also perpendicular. And guys, this right here, this triangle right there, we'll call it BDA, is an isosceles triangle. The nice thing about this picture is that this CBD is also an isosceles triangle, because the radiuses, or the radii, if you want to be particular, are equal. And then we have this point out here, just for good measure, we got this diameter EB. So if I tell you that this here is 40 degrees, you should be able to tell me what each and every angle in this picture is, because you remembered that CBA is 90 degrees. You should be remembering that CBA is 90 degrees. You should also be remembering that CDA is 90 degrees, not only from the first part of this video, but from your lesson in class. Okay? So those are 90 degrees. Okay, so I know that the measure of angle CBA is 90 degrees because of the property of a tangent line and the radius or diameter where they intersect. But that also means that I can find this angle right in here, angle DBA. Well, because this is an isosceles triangle, then I know that these two angles here are congruent. And so I can take 180 minus the measure of angle A and then divide that by 2. And that's going to give me the measure of DBA, which I believe is 70 degrees. 40 away from 180 is 140, divided by 2 is 70. Well, so that also means that the measure of angle BDA is 70 degrees, because this is an isosceles triangle. Base angles are congruent, and all three angles add up to 180 degrees. I can then also find this angle CDB right here, because it's congruent to CBD, and I know that this whole thing is 90, so the measure of angle CBD is equal to 90 degrees minus the measure of DBA. And I know DBA is 70 degrees. That means the measure of angle CBD is 20 degrees. But that also makes the measure of CDB 20 degrees as well. And then the last thing here, we have the measure of BCD. BCD. Well, it's real simple in that it's the quadrilateral here. This is a quadrilateral. So if these are 90 degrees and this is 40, then all four of the angles add up to 360. So I can take 90, 90, and 40 away from 360, and I can come up with my angle here in the middle. But I don't necessarily need these two, because 90 and 90 make 180, which is half of 360, which tells me that the measure of angle C plus the measure of angle A, that's equal to 180 degrees. Well, I know angle A is 40, which means the measure of angle C is 140. And so that's how we identify and solve for the angle measures for all these things. But you then are going to come to a little bit of algebra, and the algebra, you use the exact same properties that we just talked about right here, except now we're solving for x. Well, angle Q and angle P are supplementary angles. They add up to 180 degrees. So 180 is equal to 2x minus 2 plus 6x minus 10. Add the common or like terms, and then solve for x. 180 equals 8x minus 12. Then we're going to subtract, actually we're going to add 12. We won't subtract, we are going to add. We'll add 12 to both sides. Get 192 is equal to 8x. And then we just divide 8 both sides to get x by itself. And I believe that 8 goes into 192. Looks like it goes in there twice. And I'm going to say 24 is equal to x. And then we can substitute x back in to where x is in the problem. And then we can get the values of our angles.